But it turns out that spinning fire is a great way of simulating the motion of a planet. And the centripetal motion of your fire on a chain is very similar to the motion of a planet under gravity. The light on my wrist represents the star, and the spinning ball of fire around that is a planet. And as you can see, the ball of fire draws out a large circle, and my wrist is drawing out a smaller circle inside it.
It's this tiny wobble of starlight that scientists use to find extrasolar planets. But even this wobble would be undetectable if it wasn't for the Doppler effect, the fact that wavelengths get shorter as the object emitting them moves toward you and longer as it moves away from you.
The Doppler effect is very familiar if you've ever heard a train going by blowing its whistle. So, when the train is coming toward you, you hear a high-pitched whistle. And as the train recedes into the distance away from you, you hear the pitch of the whistle get lower and lower in frequency.
Just like sound waves, light waves appear to shift in frequency as the object emitting them comes toward or away from you. Light from an object moving toward you will look slightly bluer. Light from an object moving away from you will look slightly redder.
When the light waves shift their wavelength toward the blue and toward the red and back toward the blue again as the star wobbles around, the shift is excruciatingly tiny. But it's that difference in the wavelength of the light waves coming at you that is what we measure, and it's what allows us to detect planets around other stars.
Using this Doppler technique, Marcy and Butler spent over a decade patiently studying 120 nearby stars for any sign of a wobble.
I went 11 years without finding a single planet, nothing. And no one was surprised by that. It seemed logical to everybody else that it was a fruitless, frivolous, maybe even lunatic exercise to look for planets of any sort.
But then, in 1995, came the surprise announcement from Swiss astronomers Michel Mayor and Didier Queloz that they had discovered a gas giant planet circling the star 51 Pegasi. Marcy and Butler rushed up to Lick Observatory on Northern California's Mount Hamilton to aim their own telescope at the star and see if they could confirm the Swiss team's results.
Yeah, there it is. Looks beautiful. Paul Butler and I were shocked to see that the wobble of the star was precisely as the Swiss had said it was. And I remember driving off Mount Hamilton from Lick Observatory in complete silence, Paul Butler next to me. We knew that the first extrasolar planet had been discovered. It was a very moving, personally moving moment.
Despite the monumental nature of the discovery, this, like all future extrasolar planets, wouldn't get the name of a Greek or Roman god. It would take the astronomical catalog name of its parent star, 51 Pegasi, and add to it a lowercase b. In this standard nomenclature, if a second planet was found around the same star, it would get a lowercase c, and so on through the alphabet. Its name was the only thing unassuming about 51 Pegasi b. The discovery shook the foundations of our understanding of planets. In 1995, astrophysicist Alan Moss was asked to review a paper announcing the discovery by two